So the last time we got together, I was trying to show you some of the differences in color spaces. And at this point, we're basically working with 4 different color spaces that we need to be aware. The CMYK, which is the smallest space, is basically the printer's standard for print media, like magazines and newspapers and things like that. And it's the smallest space. And right now, all of us are looking together in the standard red, green, blue color space, which is this one with a yellow box around it. And that's what our computers show and what we end up printing and sharing things in. It's the space that JPEGs are in. The next largest space is the Adobe red, green, blue space. That's this larger one here. And then the largest one is what this chart is calling the wide gamut, which is basically Pro Photo, which represents all the colors that our cameras currently can capture. And then that blob of color in the background is what we can see. There is another color space that we use called lab color, LAB color, and it's all of the colors in the visual spectrum plus some colors that don't exist. And it's a mathematical formula which has its uses, but probably beyond our everyday use. Now, what's important about this? Mostly what's important about this is that we can only see the sRGB colors currently. And some people therefore would be suggest that that's the color space that we should use. However, the newer, I think our new television set, it's not really new now, but it's been new, does all of the Adobe RGB colors and a few more. And I was looking at a monitor that doesn't quite go as far as the wide gamut, but much larger than even the Adobe. So the technology is getting to the point where we'll be able to see more and more of these color spaces and that are useful for us. From an editing point of view, I like to use the biggest one I can because it gives me more mathematical space to achieve results that I want. So does that pretty much make sense to everybody?
Yeah.
Yes.
Okay, now, as far as we're looking, in each of these color spaces, if you go down here to the red corner, each of them is showing you the most red it can. And on our monitors, it'll almost always look the same because most of our monitors can only do the sRGB color space. So here be the colors. And I'm using the painter's color wheel rather than the technical color wheel because I think it makes more sense as we're trying to do color harmonies. So here our primary colors are red, yellow, and blue. That's that moving there. As opposed to red, green, and blue, which comes in closer to what our eyes actually see and how our computer monitors work. So I'm going to click on the screen here. And if you look on this chart right down in here, you'll see the formula to make that color. And the formula for that color is no red, 255, which is the most we can have of the green color, and no blue. That work for everybody?
Yeah.
And that's a formula. And it's expressed in basically in 5 different ways. So we got the hue, saturation, and brightness thing. And the hue would say that on the color wheel, this is in the 120th degree mark. So the color wheel in the HSB thing is 360 different colors that it can have, up to 100% saturation and up to 100% of brightness. Down here in the RGB section, we have a maximum of 255 units or shades of each of those 3 colors. lab divides the colors into the A groups and the B groups, and the top one has to do with the contrast and brightness. So that's a little bit more precise. And down here we have the colored inks. So cayenne, magenta, yellow, and K stands for black ink, which makes those show up better. And then we have this number here, which is in fact the address of that color for all kinds of aficionados. So I'm gonna click over here to the green, or to the red, and you'll see this one messed up because I fixed it. Let me use this red. To the red, which has the formula of 255R, no green, no blue. If we look at the red purple, we can see that blue is added. If we look at the red orange, we can see the green was added to make that color. So there's our color there. And the last one we look at for this exercise is blue. And that's the same effect. No red, no green, and just blue, just as you would expect it to be. So are there any basic questions about that? Okay, so those are the numbers of the colors that we just looked at. In the sRGB, so the red is 255, the green is 255, and the blue is 255. If I were to take these colors and move it into a different color space, I'm going to convert the color profile, and I'm going to convert it to Adobe. So what we're going to look at here is those same colors. So we started out with, let's put the red here. So the red in this color space is 219. So it's the same color on your screen, but because Adobe RGB is a larger color space, this isn't using all the reds in it. It's using about 20% less of the reds that are available. In the greens, the green here, instead of being all green, it's green, but it has additional red and blue in it to make the color that we want. And if we come over here to the, what's the blue I want? To the blue, you see instead of being 255, it's 250. Okay, so there's a difference. We have more range in this color space, and we're not using all of the red, all of the green, or all of the blue that's available to us. If we take this in the other direction, let's go up here and go ahead and go to ProPhoto, which is the wide gamut that was on my my box before. So look at my colors, and the blue now is still at 250. The red formula has changed again. And so has the green. And so has the green. Okay. So you would expect these to be different numbers because the amount of colors that's available is much, much larger. If we're working in ProPhoto and then bring it on down, so let's take this now. And move it, and now that we've changed these colors, we're going to move it back to the sRGB. So the green, we still have the 255, but there's now, as it was converting itself back from the ProPhoto, it's got some red in it and some blue in it that wasn't there before. If you look at the red, we still have all of the red available because that's all that's available in this color space. But we also have some green and some blue present that wasn't there before. And the same is true with the blue color. We have our blue, but we also have some new colors coming in. So when we're talking, and I'm telling you that it's important When you're just write these down for us. When you're converting, to be conscious of the fact that as you convert down, the colors can shift. And these are the numbers from this demonstration right here of those primary colors for our computers. And that's true for all of them around the wheel. Each of them will shift a little bit as we're going through this process. So, does that clear that up a little bit?
Yes, it does.
So, Richard, I have a question, and that is, so from what I'm seeing, there is a greater range of color available, but this is dependent on the monitor and dependent on the printer. Is that correct?
Well, they're available irregardless of what monitor you have and what printer you have.
Yes, but for you
monitors-
to see that, but for you to see that difference,
Well, some of that technology is changing. I just downloaded the update for my DxO program, and it's figured out how to show more of the colors in the color range. It's showing a little bit beyond the Adobe in its color range as it renders it. So software-wise, we'll be able to push the envelope a little bit. And monitors, as they get better, we'll be able to show you. When I first started with IBM type machines, we only had 8 colors, and we only had 8 bits. And the monitors have gotten steadily better. Anybody bought a monitor recently?
no.
Yeah, but it says RGB,
It's just RGB.
sRGB.
They're available right now in the
I didn't want to spend the money.
well, yeah, in the $1,000–1,400 range that does all of Adobe RGB plus a few more. And if you're willing to spend several thousands, not quite the price of a new car, but getting close, you can get a whole bunch more. So there are monitors now that are available. Most of our printers are not able yet to print in all those colors, but you know, the way of the world is that it's going to be. So that's just where the future's going. So why is it important to use in a larger color space? It's mathematical. If you've got more different ranges of colors and you go to manipulate them, you've got more places in between to stick the color that you're using. You know, Bob's favorite example is if you only have dollar bills and you have $7 and you want to split it between 2 friends, what happens? You know, one gets $3 or one gets 4, or one gets 3, the other gets 3, and you keep $1. But you can't split $7 between 2 people. So if you have 2 different colors, like a red and a red orange, and you want to blend them together to find that middle point to fill in the space that was missing, it hasn't got a place to put that number so it can satisfy it. And you say, well, hell, what difference does that make? You got to go back to the smaller numbers anyway. But it makes a difference in which way it tips the scales when you do that conversion down. Does that make
Can
sense?
the naked eye see the difference, Richard?
Well, depends on how good a monitor you've got. Where you'll see the difference a little bit, especially if you're making the change down, is oftentimes, if I'm not careful, and I just take a pro photo thing and send it out as an sRGB, like in a JPEG or something, the colors are not the same, and I can see that. If I convert correctly, the numbers are almost identical because I'm looking at it through the same kind of a monitor. Now, if you're working on cell phones and Twitter and Facebook and that stuff, it makes no difference at all. Matter of fact, most of the stuff doesn't make very much difference. But if you're doing high-end printing, or you're sending your stuff out, or you're doing a lot of edits, that larger space will give you more bang for your buck. When you, for example, take noise out, remember we take noise out and we make things fuzzy, we blend the colors together. The more colors you've got to blend, the more naturally you can take that noise and make it go away. And that's probably the easiest example where you can see it. Because when we reduce noise, we're blending pixels.
Richard, if I am playing with the color ones and I'm doing a black and white, will
Yes,
you pick up the difference in the shadings?
yes. Now, will you see it? It depends on how young your eyes are and how compulsive you are. You know, black and white is an oxymoron kind of a thing. It seems like it should be simpler, but I've tended to find that it is far more challenging to do it well than it is to do color well. And maybe that's because in color, I know I'm manipulating my perceptions. When I'm working in black and white, you know, I'm kind of harkening back to what I saw in the 50s. And that's how I think black and white's supposed to work. Remember, the Long Ranger had a light gray shirt, and when I saw that it was blue when we got color television, I couldn't watch it anymore because it was wrong. It was just wrong. So this whole color thing has so many layers to it, and our perception and understanding of it changes. At least my understanding of it changes the deeper I fall down that rabbit hole. But I wanted to share that with you because that's the thought process and the reasoning behind changing your pictures into the smaller color space before you submit them to a competition or to a printer, and then looking at them. So the big word here is don't trust the machine is going to do it right, because it's not. It has its own logic and it's not ours.
Let me
Now-
underline a couple things there, Richard.
Okay,
If you're submitting for competition, particularly for DippySig, make sure you check it in sRGB, because that's what our judges are going to be looking at it in before you submit it. That was the first thing. The second thing is regarding Donna's question about does it matter? I've been doing a lot of printing, black and white monochrome printing here lately. It's actually monochrome, and my printer ran out of cyan ink today. Because Epson is smart enough to know that if you want to do a certain paper in monochrome, they're going to add a little color to it to make it look right. So it's more than just what you think it might be.
yeah, our black and whites will use all of the colors that your printer had to use it to make the shade of gray. Or if you're going to a sepia tone or a platinum based
Yeah.
image, it'll use all the colors that your printer will allow it to use.
Yeah, well, these were converted to black and white in Lightroom. So theoretically, there wasn't any other color in there. But the printer, I'm using Epson Print Manager, and it knows for a particular paper to put something else with it.
Now, when you're doing this, you have that option when you're saving the print, whether you should embed the color space. And my current thinking is that you always should.
That makes sense.
Because when I try to open up an image where you've embedded the color space and my program goes to open it up, it has a lookup table where it can say, oh, this is supposed to be in Adobe RGB. And on my machine, that means make the red this color, make the blue that color, make the cyan that color. So it makes the transition closer to what it was you saw on the other monitor. You know, two of you have sent me pictures to look at that were out in a minute, and in each of them, I've tried to accept or keep the color space that you had so that my machine translated them the same as yours did. Okay, so embedding your color space is a good deal. So questions or thoughts about that? Okey-doke.
When you down convert, if you see something change,
Yep.
what kind of options do you have?
Well, you've got a bunch. If you can identify what changed, you can go in and adjust that color, and we'll look at that, which panel we used to bring that up. But then you might change it and how you brought it across. For example, if you're working in ProPhoto, so ProPhoto is the biggest color space, and it uses the largest bit depth that you have available. So the technique there normally is to try and adjust your image. And then before you change the color or the bit depth, size it to what you want it to be, so that it can use all of the math and the color to figure out what it's going to combine or throw away to make the new smaller image. And then convert the color from the Pro Photo or 16-bit color down to the 8-bit color, so that it has all the information at the right size to make the conversions. And you can find if you follow that sequence, your chances of coming out correctly are better. But if you just take your Pro Photo huge photograph and use the export function in Photoshop, you're up to the whim of whatever the engineer dreamt up that morning as to how it makes those combinations. And I have the utmost respect for engineers. It's good that somebody can be that compulsive. But for the rest of us, we need a little bit of flexibility here to kind of get the color we want. How many of you have seen Mr. Blair builds his dream house? It's a movie from the 30s of Mona Lloyd and Cary Grant. And there's a scene in it where she's telling the painters what color she wants things painted in her room. And she goes, well, I want this room to be cheerful and happy. And I want it to be yellow, but not just any yellow. I want it to be daffodil yellow, but daffodil yellow as the sunlight reaches early in the morning. And the powder room, I want it to be blue, but not just blue, not quite sky blue, but not as rich as robin's egg blue. Maybe something more like periwinkle blue, the lightest one near the bottom of the petal. And as she walks away, one painter looks to the other and says, yellow, blue, make that one white. So that's kind of where we're at. We have all these colors that we know how to describe and move. But in the end, the printer's going to do what it can. It'll do the best job, but it has a limited palette for it to work with. Still, it's huge. I mean, it's more than the box of crayons that I own, but it will work better for you. So just keep that in mind when you're doing that kind of work.
This
We're-
is just a quick question that doesn't relate to this. Like when you get Sherwin-Williams paint or the paint, are they using that Pro Photo? Because they have all these little numbers all over when they mix up the paint.
And those numbers are the formulas from there to put the tints in the various baits. And so it's something similar. But once again, it's, when you go to Sherwin-Williams or you buy the Bears or whatever the thing is, it's usually a can of either a cold white or a bright white paint that they use as the base, and they just stick dyes in it. It's like when you go to, I went with Susan to the hairdressers the other day, and I said, I'll get a bottle of brown and a bottle of orange, and you got the color you want. And no, they have all these little bottles they mix together to make hair. It's exactly the same kind of a thing. And by the way, they make charts. I have no idea where mine went. Flip things like paint chart strips that show all these different colors that you can make, that you can pick them. And printers use them when they're trying to match a color in an article or in an ad. So they say, the color I want is you have two choices. You can buy the ink separate. This is where the PMS colors come from that's in our charts. And those are colors that were mixed and sold specifically to the printers to get the right color for the logo for Kellogg's or something. Or they have a cheat around that says, well, we're not going to buy that one ink, but if we mix the standard inks in these proportions, we'll come close enough. And the answer always is, how close is close enough? And, if you're doing it on Facebook, it doesn't have to be very close. Okay? It's good you answered that, Don, and I'm glad you're here because we're going to attack your picture next.
When you go out to a good high-end commercial printer,
I'm sorry?
when you have something printed by a high-end printer out in the commercial market,
Yes.
were they usually printing in sRGB? Are we getting into Adobe? Or
Depending on how high they are, they're going to use, first off, they're going to print in CMYK. That's the colors that printers use. And then they have specific colors you can add to it, like green or like purple or a specific ink that's going to be used that they buy from PMS to put that specific color into the mix. And so a commercial printer prints each page one time for each color you're using when it goes through the presses. So they don't print it all at once. So there'll be a run of black, a run of cyan, a run of yellow, a run of. So that's what we do. When you look at a page, sometimes one of the colors is off to the side. That's because they didn't get the pages lined up correctly. Okay, so that's what's going on there. So big presses, all presses are going to run with the 4 inks. And then oftentimes, depending on how much they're going to use of a color, there might be a 5th or a 6th ink added to it. But on really high-end printers, they could have 8, 12 runs of colors.
So if you're going to be going out, if you're going to be going out and getting something printed by a good quality company, then working in the higher end levels with, say, Adobe is worthwhile.
Maybe, but they're stuck with the same, most of them are stuck with the same monitors we have. Because it's a commercial business and there's not enough business normally to generate that. So normally you're set to the 4 inks, but you can do an awful lot with those 4 inks. And it's, as you saw back on that first chart, it's very similar to the Adobe colors. Okay,
Okay, thank you.
you're welcome.